Okay, let's do a little review of the concept of convection. Convection is, well, if the atmosphere, it's hot air rises because it's less dense than the surrounding air, right? You remember why a cork floats in water? Well, it's because it's less dense than the water. So the water is more dense, it's heavier, it's trying to push down, so it'll push the cork upward. That's the buoyant force, right? So what ends up happening then, if you have less dense air surrounded by cooler, more dense air, it will rise. Now, the same kind of thing can happen in liquid and water, like when you're boiling some water on the stove, or it can happen like inside the Earth's interior, where you have the inside the Earth, you have an area, say, in the Earth's core that's hotter than the surrounding mantle that will cause a convection current. And so this is what drives plate tectonics. It's what drives the weather, what makes the winds blow. It's a pretty important concept. It's called what? What's the word? Starts with a C? Convection. Okay, so let's do a little bit of a demonstration of convection, Mr. Bunsen burner, so that'll add some energy to it. So that heat energy is making the molecules of air move faster and faster and faster, and so they're pushing each other away because they're pushing with more energy. That means that they're expanding, which means there's less of them in a given volume, which means it's less dense. So the cooler air around it is more dense, so it will rise. Like, well, let's see what happens. If I can capture some of this hot air in this garbage bag, what's this like? Any of you guys ever ridden in a hot air balloon before? It's exactly like this. So here you can see that the hot air is collecting inside of the bag. Hey, what did I just say? Hot air what? Because it what? That's right. Hot air rises because it's less dense. And that's known as what? Starts with a C. Convection. Okay, so anyway, feel a little bit, I'm going, anyone? Bueller? Anyway, here we go. Hot air rises because it's less dense. Woo! And there it goes. Oh. Convection. Okay, now I'm going to do another demonstration of convection. What I have here is a glass tube. It goes all the way around, and it has a little opening at the top. Now, this, I don't know if you can see it very well, but it's full of water, except for right there. And what I'm going to do is add just a little bit, one drop of food coloring. And now remember, what makes it happen on the Earth's surface for the atmosphere is the uneven heating of the Earth's surface. The one place gets heated more than another place, and that means one place gets warmed up more than the other, and you get a convection cell. The same thing happens inside the interior of the Earth, where you have some part of the core, presumably, it gets warmer for some reason, unknown, and it starts a convection current inside the Earth's core and the mantle of the material there. So this can happen in all kinds of different situations. It's the same basic physics in the atmosphere for making the winds blow, and inside the Earth's interior for making plate tectonics, and right here in this little tube, the exact same physics are at work, which is pretty amazing. It scales up to the scale of the whole entire planet or the whole atmosphere, or right here on a lab table. At any rate, so what I'm going to do here, so you can see it, I'm going to put one drop of food coloring. Okay, one drop of food coloring. Now what happens when I heat one side with the Bunsen burner here? Watch what happens. Doesn't look like much, does it? Well, as this side gets warmed up, what's happening? Can you see it? See what's going on there? It's going around the tube. And so what we've done here is set up a convection circulation cell, a convection cell it's called. Pretty cool, huh? Okay, so here's a candle over top of this kind of a fluid. This is sort of an interesting fluid. It has these little suspension things in there, so you can see the movement. And what's going on here, as the candle heats it up, it makes it convect upwards, right? And so it's making the fluid flow up. Now that's the same thing that happens in the mantle of the Earth. And notice what happens on the top. As it flows up to the top, it's going to spread out, right? And so that's what's basically this process of convection. The same thing that's happening in this little jar, The same thing that happens like with the balloon over the Bunsen burner is works inside the Earth's mantle, inside of the interior of the Earth, where the mantle material will rise to the surface and then push the continents outward. It split Pangea completely in half. Now it's driving the continents away from each other. That's seafloor spreading, driven by convection. Alfred Wegener was right. Okay, so here's a box here. And this box, it has these little gears and stuff. And you can figure, oh, what if there's a little convection cells going round and round, where the hot magma down here will rise to the surface. And what that will do is create new seafloor, and it'll spread apart, right? Well, what if you have these slabs of granite, these basically the continental plates, floating on the more dense basaltic magma, right? The mantle. It's floating on the mantle. Now, what would happen if you had new seafloor forming between them? Yeah, they would move them apart, right? And so the fact that you have new seafloor forming in the middle of the mid-Atlantic ridge is going to send the continents away from each other. It's going to make them drift. So it's not like they're going through the seafloor. They're actually just floating on the mantle as it spreads apart. And that's all driven by the process called convection. Say the word out loud. What's it driven by? Convection. There you go.